Now we are ready to define the instantaneous rate of the change according to the record 2.4.1 after the learning the rate of the change. So we can define the instantaneous rate of the change. Okay, so for the again for y equals f of x, the instantaneous rate of change at x equals a equals limit when h goes to 0 f of a plus h minus f of a over h. So this limit is the instantaneous rate of the change, of course, if the limit exists. In general, the adjective instantaneous is often omitted with the understanding that the phrase rate of the change always refers to the instantaneous rate of the change and not the average rate of the change. So similarly, velocity always refers to the instantaneous rate of the change of distance with respect to time. Okay. On the other hand, we talk about the slope of the tangent line. So slope of the tangent line. If we turn back the first part here, we had two problem that steps. One of them is the discussed, so the physical phenomena, falling steel ball, and the second one is about the graph. So this is about the tangent line. Okay, so here our interpretation of the difference quotient have been numeric in nature. Now we want to consider geometrical interpretation. Okay, in geometry, a line that intersects a circle in 2 points is called a secant line. So here for the circle, this line is secant. Okay, is the secant line, so T, secant line. And a line that intersects the circle in exactly 1 point is called a tangent line. So that is a tangent line. This is tangent line. If the point Q, this point denoted by the Q, maybe we can show the tangent at the same point. Okay, so let's change our tangent line. It is better to use the same point. So here, this is tangent. Okay, so let's say this point is P and that point is Q. Okay, so if the point Q, this point Q, is moved closer to the point P, if this is closer to that point P, so I mean like that one, this is the Q, okay, this is Q, this is Q, this is Q, this is Q. So the red line approach the green line. Okay, we will generalize the geometrical concept of secant line and tangent line of a circle, and we will use them to study graph of the function. Okay, so a line through 2 points on the graph of a function is called the secant line. If let's show that for any graph. For example, this point at that point PQ. So this is second line. So let's say this point is A, and this point is A plus H. Actually, x component of the point P is A, x component of the point Q is A plus H, okay? So this is capital P, this point is Q. Actually, that point, this point is A comma f of A, and this point is A plus H comma f of A plus H. Are 2 points on the graph, so these are 2 points on the graph. Then we can use the slope formula for this situation to find the slope of the second line. Okay, so what is the slope of the second line? So the slope of the second line is this distance, which is f of A plus H minus f of A over that distance, which is H. So over H. Over H. This is the slope of the second line. If here H goes to 0, if H goes to 0, or A plus H approached A, or Q approached the point P, with the limit notation, you will obtain the same definition, this definition. So this limit will be slope of the tangent line, okay? So here you will obtain the tangent line. So the slope of the tangent line, let's write here, slope of tangent line is limit of the f of A plus H minus f of A over H as x approach 0. So this situation can be given as a definition. In your textbook you can find this definition. Of course, for the given function y equals f of x, the slope of the tangent line, of course, at the point x comma A comma f of A. So at this point we talk about the tangent line. Easily you can write the equation of tangent line since you know the point and you know the slope of the tangent line. So easily you can write.